So far, we have now for a while been drawing graphs in the classical fashion with dots representing vertices and lines or curves representing edges. This is all fine and very intuitive, and we're going to continue to do it this way. But in some situations, you want to have a more systematic way to represent a graph. For example, if you want to enter it into a computer that doesn't understand your beautiful drawings, but needs numbers. And the answer to that, as is the answer to so many things in mathematics, is surprisingly matrices. Matrices are very handy. Same kind of matrices you've seen in linear algebra, you can use here. So for now, we'll just look at matrices as ways to encode the structure of a graph. So the situation is this: you have a graph with n vertices. Number the vertices from 1 to n, why not? Now, there are essentially two ways to encode the information about the structure of the graph into the matrix, into a matrix. And this can be done in terms of an adjacency matrix or an incidence matrix. Let's look first at the adjacency matrix. So the adjacency matrix is an n times n matrix. N is the number of vertices of your graph. And the ij entry in the matrix is the number of edges joining vertices I and j. So let's see how it looks. Assume we have the following graph with four vertices, and I number them 1, 2, 3, 4. So the adjacency matrix of A will be a 4 times 4 matrix. So I will number the columns 1, 2, 3, 4, and the rows 1, 2, 3, 4. Of course, you don't write these numbers in the matrix, but I just want to be clear what's going on. So how many edges go between vertex 1 and 1? There are no edges. There is one edge between vertex 1 and 2, so I draw a 1 here. There are 0 edges between vertex 1 and 3, and 0 edges between vertex 1 and 4. Now let's look at vertex 2. Vertex 2 has one edge to vertex 1, no edges to itself, 2 edges to vertex 3, no edges to vertex 4. Vertex 3 has 2 edges back to vertex 2 and no edges to any other vertex. And vertex 4 has no edges whatsoever to any vertex. So this is the adjacency matrix of this graph. Another way is to record the incidence matrix. Now you not only need to number the vertices, but also the edges. And this is an n times m matrix, so as many rows as vertices and as many columns as edges. And its entries are going to be only zeros and ones. You put a 1 if there is indeed an incidence relation between the vertex and edge in question, meaning that the edge actually goes to that vertex, and 0 otherwise. So let's look at an example. Let's look at the same graph. So let me draw it bigger. Remember, this was this graph. So I had my vertices 1, 2, 3, 4. And now I must also number the edges, and I number them 1, 2, 3. So M is going to be a 4 by 3 matrix. So here I have 1, 2, 3, 4 rows and 1, 2, 3 columns. So these are representing my edges, and these are representing my vertices. And now I'm asking a yes or no question for each pair. Does edge number 1 go to vertex number 1? Answer is yes. So I put a 1. Does edge number 2 go to vertex number 1? No. Does edge number 3 go to vertex number 1? No. By saying go to, I mean, is it incident to? So is edge number 1 incident to vertex 2? Yes. Is edge number 2 incident to vertex 2? Yes. Is edge number 3 incident to vertex 2? Yes. So this row of yeses or ones means that all edges in fact go to vertex 2. Vertex 3 is only incident to edge number 3, 2 and 3. And vertex number 4 has no edges to it. So this is the incidence matrix of my graph. Now, I want to ask you a few questions. What about loops? What properties does the adjacency matrix have? And what properties do the columns of the incidence matrix have? Think about this for a moment, go back and forth in the slides, and I will give you the answers in a short moment. So let's talk about loops. If you have, say, this kind of matrix, so here you have 1 and 2, this kind of graph, what is the adjacency matrix? So it's going to be a 2 by 2 matrix. I have 0 edges from vertex 1 to itself, 1 edge from 1 to 2, 1 edge from 2 to 1. How many edges do I have from vertex 2 to itself? I only have the loop, but there is a convention that loops count as 2 edges. This is the same as the 2 endpoints, but here really the philosophy is that there are 2 ways to follow one edge from vertex 2 to vertex 2. I can go clockwise or counterclockwise along the edge. So this corresponds to a loop. What properties does the adjacency matrix have? I'm sure you found all sorts of interesting properties. The main one is that it is symmetric. So a symmetric matrix has sort of the mirror image below the diagonal identical to the one above the diagonal. That is because this edge is an edge between 1 and 2 and also between 2 and 1. And since we don't care about the order, we're going to get a 1 here and a 1 here. And we got the same thing in this previous example where you can see how the matrix is symmetric. What about the incidence matrix? Well, the only obvious property is that each column has exactly 2 occasions of 1, because each edge has exactly 2 endpoints, and that is where you put the ones corresponding to that edge. So these are the properties of the incidence and adjacency matrix.